So I'll have 6 fragments. Of course, I'm gonna mix these 6 fragments. Then I'm gonna assemble them using the exact method right here. You should check the video out if you didn't. The link will be in the description. I'm gonna keep like 5 microliters of the assembly for electrophoresis just to see if my fragments got assembled. I'm gonna transform the whole assembly reaction, of course, into E. coli. I do have another video on that also, link in the description. And then I'm gonna pick from the colonies that I'm gonna get a certain number, and then I'm gonna screen them. I'm gonna do using restriction digest. Basically, I want to see the exact percentage of the correctly assembled plasmids from the total number of colonies that I got. So basically, I'm just gonna try to determine the assembly efficiency of my method. If you want to check this out, of course, I'm gonna go into detail, and basically this is gonna be a how-to video, so you can follow along. And of course, if you like and find it useful, just leave a comment. So without further ado, let's go into the whole protocol for the assembly. Okay, so secondly, let's choose the fragments. These are the fragments right here. Let me just see what's available, right? Sorry about this, I'm doing this with one hand. So these are my fragments right here with an S over them. So I'm gonna need a promoter. This sounds good, so the SV40 promoter. I'm gonna need the ampicillin AmpOri. Okay, let's just say these are right. So these are my 6 fragments that I'm gonna need to put in one tube and clean and concentrate using one of these kits. Right here. And then I'm gonna assemble, and then I'm going to transform. So 6 fragments, 1 plasmid. This is the PNN SV40 BGA. Okay, so let's put these fragments into one tube right here. So this is gonna be NN SV40 BGA. I'm gonna put 10 microliters of each fragment. Into my assembly. This is 10 microliters. So let me get some tips. Okay. So this is gonna be the AmpOri fragment. Mix it a bit. Okay. Huh. There you are. Now I'm gonna put the promoter. Then the smart region for the smart fragment. The same, should mix it a bit. So you can put any fragments you want, right? As long as they have the overhangs. I told you in my other videos, especially in the Golden Gate assembly one, how this goes. So this is the GFP. All of them are stored in shield. You can see that right now I'm freezing them, I'm thawing them, and so on. With this method, you basically could do like 8 different assemblies per fragment, because you after the PCR you're gonna put in 60 microliters of shield, so this will give you a total of 80 microliters, right? So if you put 10 in the assembly, that means that you're gonna have enough for 8 separate reactions. So this is the terminator right here. And the last one is the DTS. Alright, so now I need to clean them. Let's see how this goes. Okay, so these are my cleaned fragments. I am going to transfer 5 microliters from here into a tube. So this one will go into the for the electrophoresis. This is gonna be the pre-assembled fragments, and this tube is I'm gonna use for the assembly itself. So 5 microliters right here. Okay. So this is gonna be the pre. So these are gonna be just the cleaned fragments, right? Pre-assembled, okay. And this is gonna go into my assembly. For the assembly, I'm gonna need BSA, T4 ligase, and T4 ligase buffer. Okay, so I've pipetted the Golden Gate assembly. Let's go put it in the PCR machine. Right, let's close it. Users, and that's me. Okay, so 37 Cs for 1 minute, 16 Cs for 1 minute for 30 cycles. and the final soak time at about 60 degrees Celsius. Let's just start. Okay, so while this cycle is running, I'm going to go put some ice for the transformation. Okay, so for the next step, since the assembly is done, I need to add 1 microliter of DPN1 to the assembly reaction in order to get rid of that background plasmid that remained from the PCR of the fragments. So let me set this pipette to 1 microliter. Let me get some clean tips. Of course, my enzyme from the freezer. Here it is, DPN1.